Lung cancer prediction using logistic regression. So, few information which I would just like to remind over here happens to be the data set for your lung cancer. Lung cancer data set, literally, I collected it from a website, Data World platform. So, you can use this URL, use this following URL, put it in Google, so you'll be getting a data set which could be used for predicting the person is having lung cancer or not. So literally this database consists of 15 attributes along with the disease, whether yes or no. So including that, that's 16. Including cancer yes or no, it's 16. Excluding that, you have 15 attributes, and altogether the training set consists of 309 informations, out of which 270 information talks about the person is having cancer, that is it's true, and 39 instances wherein the patient is not having lung cancer. So you can say that the total number of events wherein the condition where you have lung cancer is more here. It's not been divided like 50%, 50 is to 50. Rather, it's very high. So you can, by comparing this, it's literally, the ratio like 80 is to 20 ratio it is. 80% of the instance the person is having cancer, and 39 instances where the patient is not having lung cancer. The attributes which we will use, or literally which facilitates the lung cancer in this case, are as follows: the gender, age, smoking, yellow fingers, anxiety, peer pressure, chronic disease, fatigue, allergy, wheezing, alcohol, coughing, shortness of breath, swallowing difficulty, and chest pain. So in the Excel sheet given to you, you might figure out the weights associated with each attributes, like 2 1. So you might question what 2 implies. 2 implies whether does he smoke. Over here, for you, if I do consider this two example, suppose if the guy is smoking, then the associated value there would be 2, and if it doesn't smoke, if it's not having any smoking habit, then it would be 1. And yellow finger, similarly, yellow finger, S implies it's 2, no implies it's 1. So this way the numbers are addressed, and this information or this attributes with these numbers would be used generally for classification. And logistic regression is a method used for classification. So classification method, it is approach in supervised learning wherein inputs are given and outputs are also given, and based on the inputs and output you derive a hypothesis, and this hypothesis is based on log function, which is generally based on maximum likelihood methodology. So that methodology is used for predicting the output, and later the predicted output and the expected output are compared, and they are evaluated again, and you do use more iterations, you compute the cost, and we will discuss in detail what those cost function is, what is the predicted output, what is the expected output, with an example. So literally, the first four patient information, all this 16 components with first four patient information is as follows. The first component is M, implies male. 69, second one refers the age. Third component refers whether he is smoking or not. So this first guy doesn't smoke, that's why the value is 1. Then yellow finger 2 implies this guy is having yellow finger, literally. And anxiety, yes. 1 implies over here peer pressure, it's no, so on it goes. So understand, just observe this value, and with respect to this compare and figure out what attributes values are for this particular guy. Now coming back, to the logistic regression, the method we will talk about, then we will go back to the algorithm, then one example, then the program. So the logistic regression is uh, used for classification, and here, when you observe, this is having altogether 15 attributes. So since it's having 15 attributes, the hypothesis when you define, which is defined as h theta of x, and since for logistic regression you are using a sigmoid function is given by this formula, that is h of x is equal to 1 over 1 plus e to the power x. And here you are supposed to evaluate first the weighted sum of the input with the or you call it as a, you compute the weighted sum of inputs, weighted sum of input, in the sense you define some weights initially, randomly select some weights, multiply it with all the features. So over here, for this case, you have altogether 15 features. So each feature is associated with a weight. So we call it as weighted inputs. So input is not directly summed, rather you multiply the input with the corresponding weights, and thereby compute first theta times x, or you call this as theta transpose x. So theta transpose x is obtained by using this formula. It is theta naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x3 so on to theta 15 x15. Why theta 15 x15? Because you have 15 features. So x1 to x15 are the features, and x0 value we take it as 1 because we want this theta naught to be is equal to this number should be theta naught. So first purpose is to evaluate this expression. Given x, this would be given, all this information would be given. So you need to convert this m back to an integer number, addressing whether the guy is a male or female, because you cannot directly take character value over here. Okay, so first obtain theta, that's the first step. Once you measure theta, then substitute that value over here and evaluate h of x. So why would you use a sigmoid function? There is a chance that when you measure this whole quantity theta transpose x, there is definitely chance, because you can figure out the values for a person. Age is very high over here, so when you evaluate this expression, this number becomes huge. And using this function, sigmoid function, you are trying to shrink the amplitude. When you obtain this value, you are trying to scale down the amplitude in such a way that the amplitude will oscillate between -1 to +1. So literally, when you apply a sigmoid function, it would be always in the interval -1 to +1, or sometimes it would also be from between 0 to 1. So that is where you get this answer, because you call this as a hypothesis. This is your output. And for the classification problem, literally if it's a binary classification, you will be having it's true or false. That's binary classification. So binary classification, true is 1 and false is 0. We can represent it with the 1 or 0. So you can think this is 1, this is a 0. 1 means the guy is having lung cancer, 0 implies he's not having lung cancer. So for binary classification, we expect the predicted output to be between 0 to 1. So sigmoid function will ensure at any cost, no matter what this value is, whatever your weighted input is, that would, when you pass it on to the sigmoid function, which is described as follows, the value will be always between 0 to 1. So this value, we can use it for comparing it with our desired result, which is always 1 not 0. So literally this will also be 0 to 1. So you evaluate this function and estimate whether it is greater than 0.5 or lesser than 0.5. If the value, when you obtain h of x or h theta of x, if it comes out to be greater than 0.5, you decide that it has to be the guy is having a lung cancer. If it comes out to be lower than 0.5, then you can decide that the guy is not having a lung cancer. This way, this logistic function or sigmoid function will help you for predicting, or literally over here, rather than predicting, we call it as a classifying whether the guy is having lung cancer or not. And here we evaluate this two function. So once we estimate the hypothesis defined as follows, we estimate next your cost function. So your objective over here in this method, your objective is to reduce the cost function. Initially you might get a cost, and that cost should be very much lower. So if at the initial stage itself, if it approaches zero, then it is actually the best value weight which you have selected, which would classify any test data being given properly. So suppose if the cost happens to be value very high, for example, let's assume it comes out to be equal to zero point 0.9. When you estimate, let's assume j of theta, theta implies it depends, this cost function depends with respect to theta. It theta changes, j of theta changes. So suppose if you are having, assume that for the first case, when you set a value of theta and when you estimate h theta of x, then you substitute h theta over here, and y of I is your predicted answer. So while doing this, assume that the cost comes out to be 0.9. For the second iteration, we need to ensure that by modifying the weights using the gradient descent formula. So gradient descent formula is used for updating the weights. So initially you pick one weights, then estimate the cost function, then use gradient descent algorithm, change the weights, change the weights using the gradient descent algorithm, then refit that weight and estimate again h theta of x, again estimate h theta of x, then again measure the cost function. So in this case, you expect the cost function to be minimized. Okay, so initially if it's 0.9 for the first iteration for some weights, by modifying the weights, the cost function should be minimized. So your objective, the objective is to minimize the cost function parameterized by theta. So when we talk about objective is here to minimize the cost function, so you measure the cost function, which thetas gives you the very small value of cost, that thetas you need to pick. And here when you update the values of theta, when you modify the values of theta using the formula, this happens to be the gradient descent formula. So using this formula, after modifying the weights, then you fit that or substitute that weights over here, recalculate h theta, obtain j of theta, this should be smaller. Again update, again it will be smaller. So you have to repeat it till you get the, till you figure out that no more the cost changes. Okay, for example, it may not go to zero, it might be very small. After probably 1000 trials or 2000 trials, the cost will be lower and lower. So it has to be. So if the cost doesn't change, for example, if when you update the theta for the next iteration, if the cost happens to, if it increases, then you have gone wrong. So that's how you can determine whether the algorithm which you are following is right or wrong. I repeat, if you want to figure out whether your algorithm is working according to your design, then obtain cost function, modify the weights according to gradient descent, evaluate hypothesis, again estimate the cost, compare the cost for the previous iteration with the next iteration. So if the cost for the previous iteration happens to be greater than the data what you get for next iteration, then you're moving in the right direction, then you can proceed, then again repeat this process. So see to it that always a higher iteration, as the iteration goes higher or higher, ensure that the cost is being reduced, so that you get a global minimum, what you call. So that's what your gradient descent is. Okay, now remember, this is what is actually what I talked about. So your objective is to minimize the cost function parameterized by theta using gradient descent rule. So it is in turn represented as find minimum of j of theta, minimum with respect to theta, j of theta, where theta j is computed using the formula theta j is equal to the previous value of theta j minus alpha times dou j by dou theta j. Okay, now we don't have any problem with respect to theta j and alpha j, but how to calculate this gradient? This is actually, you call it as dou j by dou theta j. You say that for thetas, for different values of thetas, how the small variation in thetas is going to affect your cost function. That's what you call it as gradient here. And you have how many gradients to evaluate? You have nearly 16 gradients which you need to determine. Okay, all gradients talks about if we modify those weights, how it is going to affect the cost function. Okay, so that's the meaning of gradient. Okay, make a small infinitesimal changes for thetas, how it is going to change the value of j. For example, if I have delta j by delta theta 0, then it says that by changing small, or by making small variation on theta naught, how it is going to affect your cost function. Similarly, if it is dou j by dou theta 1, then by making small modification to theta 1, how it is going to change your cost function. Okay, and the formulas to estimate the gradients are given as follows. So you need a calculus here. You will be using a lot of mathematics over here to get this derivation for finding the gradients, which you can refer. I have already given you a documentation from where you can figure out how to estimate these two quantities. So first one is the gradient dou j, that is cost function with respect to dou theta naught. It is 1 over m. It's simply first what you have to do is the predicted output. H theta is known as the predicted output and y is your desired output. So subtract all values of the predicted output with the output which is given, and sum it up over from 1 to m. So that's how you obtain your theta naught, dou j by dou theta naught. The other values of thetas starting from 1 to 15 are obtained using this formula. It's 1 over m. So it's similar to this, but you have a weight associated which is equal to xj. For example, if I'm supposed to find dou j by dou theta 1, it's given by the predicted output, that is hypothesis predicted output, minus the expected output, which is given in your problem definition, multiplied with the x values. What is this x? This is your input. So if j is equal to 1, then this becomes xj, x1. So x1 features are multiplied with the you are multiplying the this gives the error multiplied with the input. Remember, in that way. Okay, and similarly, if it's theta 2, then this becomes x2. So x2 features, probably how many features you have? 15 features. So x2 features are multiplied with the error which you measure between the predicted and the expected answer. So hope this makes sense. So just remember the formulas which you will be using here for obtaining the lung cancer classification problem. Okay, so this is your algorithm. This is your algorithm, very important. So first step, as addressed, theta, which we are supposed to estimate given by this equation, we can initialize it to 0. So no problem, that you don't have any confusion. So suppose in this case we have 15 features. So set all the features 15 to 0. Right now, since we will be using theta naught again, theta naught also, so altogether you will be having 15 attributes plus theta 0 value. So altogether you have 16. Okay, 16 weights you have, theta naught to theta 1. So all are set to 0. So you don't have any confusion. The second step follows as estimate theta times theta 2 into x. Okay, find theta transpose into x. So what is this 3 theta transpose? Theta transpose comes out to be now a column vector. Okay, theta transpose will be a column vector and x is a matrix, and in x, what is that you're gonna fit? So x will have all 15 features. All 15 features of your inputs would be placed in your x matrix. Along with that, the first column elements will be made 1. So we do this because we expect theta naught in the equation right over here. We expect theta naught to be obtained here. So since you don't have, this is not dependent on x1, so theta naught times 1 is theta naught. So the first column elements all are made 1, because of which we expect this as the answer. Okay, to get this we make those modification. Okay, then obtain hypothesis using equation 2, that's your step 3. Then compute the cost function j of theta from equation 4. Then compute, so let me go back here. So equation 3, you estimate theta time theta transpose x, told. Step 3, obtain hypothesis is given here. So estimate equation 3, then estimate equation 2. First you set thetas to 0, so 3 steps done. Then compute the cost. So how do you measure the cost? To estimate the cost we require hypothesis and the output. So we obtained h theta, now we know what is y, then definitely we can compute the cost function j. So once we estimate j, then re-evaluate the gradients, find all the gradients like dou j by dou theta naught, dou j by dou theta 1 till dou j by dou theta 15. So measure all the gradients starting from theta naught to theta 15. Okay, for that we will make use of these two equations, that is equation 6 and equation 7. So this helps you to evaluate the gradients, because we know the hypothesis and also we know what is the desired output, and also the inputs are known. So since we have this in our hand, we can definitely evaluate these two components. Once we measure this component, that is the gradients, then you have to update the weights using the equation 5. Use equation 5 and update all the weights from theta naught to theta 15. After updating the weights, which is defined in equation 5, then go back and re-estimate hypothesis. For that again you require equation 3. So what I've done, after updating the weights, go to step 2. So equation 3 you need to implement, that is again you find theta transpose x, then again compute hypothesis, then estimate cost, then again repeat this process till the cost function keeps on reducing until you get the value j very small. Okay, then after 10,000 iteration or 1,000 iteration, ensure that you stop the process. And following the iteration, like say that we give the iteration as 1,000, after 1,000 what is the weight which you get, that is theta naught to theta 15, use that, because those are your best possible weights for your system. So use that weights, and later no matter any random input if it's been thrown to you, you can measure the output according with respect to that weight, and that will give you the correct answer whether the guy is having a lung cancer or not. I repeat, once you come up with iteration, say that after 1,000 iteration you will get some thetas. So store that thetas, use that thetas for estimating or classifying your test data. Okay, so you can again, how do you estimate? So say that for predicting, as defined, this is your last step for predicting new data. So optimal weights which you find, that is thetas which you obtain in step 3 after say 1,000 iteration, use that and compute the hypothesis. Okay, compute hypothesis, that is from thetas obtain this. Okay, step 3 you find, then the hypothesis will have a value between 0 to 1. Now what if the value of hypothesis comes out to be 0.2? So you say that, there is a chance that it's 20% it matches, that's what it says, which means if it's 0.2 then it's something like it is false. Okay, so threshold you can set it as 0.5. If the value when you evaluate the hypothesis comes out to be greater than 0.5, then you say that the guy is having cancer. If it comes out to be lower, then you say that the person is not having a cancer. That's how the method works. Okay, now let's talk about the method. So the problem statement, so I'll not talk about this. Take it as an assignment. I'll provide you this detail, just work out in a handbook or so. Just see to it that how it works for an simple example, wherein what I've done is I've taken two features rather than 15 features. I've taken two features, and here you have the features are smoke and chest pain. So this components I've taken. X1 is now smoke, and X2 is chest pain. So you can see that the first person is having he's smoking and he's having a chest pain. Second person again smokes and is having a chest pain. Third person doesn't smoke, doesn't have a chest pain. So literally for these two cases you expect he will not be having lung cancer. So X is created in this manner. So X1 is a column vector, X2 is a column vector, Y is also a column vector. So X and Y will be given to you. So literally they won't give you this capital X directly. You have to create this capital X by stacking the inputs in this manner. X1 and X2 are stacked in this manner, and the first column is made 1 because we require thetas. And here the theta value, what you do is you find H theta transpose X, that is equation 2 is obtained by the following statement: theta naught plus theta 1 x1 plus theta 2 x2. So use this equation and obtain theta transpose X. So this and this this one should be multiplied with theta. So you can figure out it is addressed here. This is actually the example wherein you measure theta transpose X. So when you calculate theta transpose X, so initially we set theta as 0. So doing that, theta transpose X comes out to be 0. So everywhere it is 0. Then you have to measure H theta of X. So H theta of X, when you evaluate, you can figure out H theta of X comes out to be all 0.5. So you can take I going from 1 to 4. You can measure H theta of X of I, H theta of X of 2 to H theta of X of 4. It is always 0.5 because this is going to give you e to the power 0. So 1 over 1 plus 1 you have. So that's 0.5 always. Okay. And use this H thetas everywhere and substitute and evaluate the cost function. So finally, when you estimate the cost function for the first iteration, you will be getting 0.693. This is your answer. So step by step I have written what goes, what stays. Okay. And the last slide is to estimate the gradient. So this formula was addressed, and it is expanded how m is equal to 4 here, because you have 4 instances. You can observe there are 4 trials. 1 2 3 4, 4 trials. Okay. X1 X2 2 features 4 trials or 4 examples. So m is equal to 4. So you can observe this, evaluate the thetas, you work on this, you can understand properly. Just do work on this. You can figure out theta naught, dou by dou theta naught comes out to be 0. Dou by dou theta 1 comes out to be minus 0.5, and dou by dou theta 2 comes out to be minus 0.25. Okay, so you can use this value, the small changes in the values of theta naught, theta 1 and theta 2. Using this value, re-estimate the value of j, and when you do so, definitely this number, which happens to be 0.693, will be still reduced, and it has to reduce. That means gradient descent is working properly. Okay, so in the next video I'll just explain the MATLAB code with respect to this program. Time being, we'll stop it here.